Welcome, everyone, and thanks for joining our event today. This is Gareth and Scott from the SciTrain team on behalf of Bentham Science Publishers and iGroup. And this event is A Picture is Worth 1,000 Words, getting the most out of your results, figures, and tables. Tonight, we'll share with you some tips and tricks on how to choose the right figures for your results and how to present your figures clearly and effectively. Dr. Gareth Dyke is here. Dr. Dyke, how are you today?
I'm doing great. Thanks, Scott. How are you? Everything okay? We're doing well.
Doing great. Doing great.
Excellent.
Thank you. Very excited to be here and happy that we've got so many people signed up for tonight's event.
Fantastic. Well, don't forget, everybody, if you've got questions, you're welcome to share them with us and we will have a look at them and get back to you at the end of the event. Right, Scott?
That's right. Feel free to type your questions anytime into the question box, and we'll get back to you as soon as possible after the event.
Bentham Science Publishers are a growth publisher, more than 100 traditional hybrid journals, and 40 open access journals. And Scott and I have been working for Bentham Science Publishers now for quite a while, right, Scott?
They've got a fantastic, robust peer review system that makes them very unique, I think, amongst publishers. They have one of the best peer review systems in the world. So you know that your science is getting rigorously checked and tested before it's published. And Bentham journals are very high quality with impact factors up to 7. And as you can see, they're listed on all the major indexes. And yeah, it's very exciting to work with the Bentham team.
We are going to be talking about how you can sell your research to readers in this event today, brought to you, of course, by Bentham Science Publishers and our partners, iGroup. And iGroup are our partners across many regions in the world, but in particular, Southeast Asia. So thank you, everybody, for joining us. I think that as we get started, really, we're going to begin with this great quote, which is really that the more strikingly visual your presentation is, the more people are going to remember it. And that's really important because when you have people reading your articles, you want them to remember that experience. Don't forget that really the most important people in the whole of the academic writing and publishing process are your readers, people using your paper. So people are going to read your work, people are going to cite your work, and one of the ways to capture people's attention, communicate your research results effectively is, of course, with great looking figures. And we'll come back to how Bentham Science can help you with that later. And don't forget, everybody, if you have questions, do type them into the chat box. We will be in touch with you at the end of the event as soon as possible afterwards with answers. We're going to talk about 4 things. Thing number 1, what to do before you begin to make your figures. Then we're going to briefly touch on different kinds of figures that are commonly encountered in academic articles, when to use them, and also when not to use them. So we'll then move on and we'll give you 10 simple rules for making and creating great figures. And then in our bonus section coming up at the end of the event, we're going to talk a little bit about tables, which sounds really, really boring, but I assure you it's not. It's going to be absolutely fantastic. So don't make the mistake that lots of researchers make. Rush on ahead and start creating figures before you're completely ready. One of the first things to do is to identify your message. Before you start to put a figure together, think about the results that you are planning to communicate. And usually what happens in research article writing is that you've finished the data collection, you've completed the data analysis, you know what the key takeaways are from your research project. So write those down and have a think about what the main things or the one thing that you want your audience to walk away thinking about when they look at your figures, because having clear and well put together figures will really, really help with the article writing process as well as the communication process in your article. So you've got a message, you've been testing a hypothesis, you've been answering a question with your research. We're going to repeatedly emphasize this in our presentation today. Keep the take-home message simple. Effective images will convey that message, that single thing that you want your audience to walk away from the reading experience thinking about. So, beginning to put your figures together, it's important to identify your key message or messages, and then we'll start to build up figures, we'll start to build up illustrations around that key message. And the second thing to do, of course, is to have a think about your audience. Message and audience are very important in article writing and planning. If you've attended any of our other training events or you'd like to attend some of our other training events, do get in touch, because we love to give training presentations on all aspects of the writing and publishing process. And we always say at SciTrain, before you begin to write, think about your message, think about your audience. And if you're putting an article together, you also need to know about the article structure. So when you start to think about creating figures, your message, and which audience are you aiming for? So which journal? What are its requirements? What do figures look like in your target journal? Because of course, different journals have different requirements. They've different page formats, they've different composition formats, they may even have different color schemes or font guidelines for you when putting together figures. And secondly, very, very important, let's think about that target audience. Of course, with most academic research papers, your target audience will be other researchers working in the same or similar field. But you might be writing a paper, putting figures together for the public. You might be writing, let's imagine, a Scientific American article or a New Scientist article, aiming to disseminate your research results with the general public. Or you might be putting together teaching materials aimed at students who may not have the same level of background knowledge, background understanding that you have as an academic. So, your message and understanding your audience, thinking about your target audience, help to guide the kind of figures that you will be putting together, because the key here is highlighting and showcasing your excellent, fantastic research, your amazing research results. And of course, don't fall into the cognitive bias trap. You know what your findings are, you understand what your research results show, but your readers do not necessarily have the same level of understanding of the topic as you do. That's cognitive bias. You've got to make sure that you logically guide your readers and show them what you found in an easy, clear, and simple, easy to understand way that gets your message across, captures their attention, and above all, makes them want to continue reading your paper. The key is to highlight and showcase those fantastic research results. Now, as we mentioned at the start of this presentation, Scott and I are not expert graphic designers, we're not fantastic artists, but we have seen thousands upon thousands of research articles, and we have talked to researchers all over the world. And so we've seen good figures and we've seen bad figures. So we're going to give you a few tips and tricks in this presentation as you build out your data presentation. And this always comes out of the results section, of course. The first bit of your academic article that you will be putting together, almost always, it's the results section. Results and methods. You collect data, you analyze, you test your hypothesis, you then put together a results section, which of course should be ordered around primary and secondary outcomes, often in the same order as in your methods section, stating clearly and simply what you found using tables and figures. We find that one of the most effective ways actually to write a results section in an academic paper is first to make the figures. Each figure, one message. Each outcome, one figure. They can be put together in panels. They can be built together within the structure of your target journal, the way that your target journal wants figures to go together. But build your figures first, because that really helps, by the way, with the article writing process. So think about your results. As we've already mentioned, that will provide you with your starting point for creating fantastic figures. But how do I know how many figures I need? I hear you ask. Well, of course, that depends on how many results you have, how many key takeaways you have from the study. But don't worry, you may not use all the figures that you make. You may use some in the appendix, in the supplementary information. You may keep some for a presentation that you may have to give in the future, or a conference poster that you might have to put together in the future. And by the way, we also provide training in all of these areas. So get in touch with us if you'd like some specific training for your research group on giving a talk or putting together a conference poster. We are going then to think about our data. We've got results. We're ready to put the figures together. What kind of data have you been collecting? Will you be collecting? How you are going to present that data is absolutely critical, because different kinds of figures, as we'll see in a minute, are appropriate for different kinds of data. And one of the common mistakes that researchers make when putting articles together, that often comes up in the peer review process, by the way, is inappropriate data presentation for the kind of data that they have collected. So again, before you start to jump into your software packages and start drawing tables and graphs and scatter plots and bar charts, what kind of data are you presenting? What's the main feature of your data? What's the message, as we've talked about before? And how will this information be used? Because again, your intended audience is very, very important. So keep in mind, of course, that your visual aids in your paper are just that. They're visual aids. They're there to assist with the interpretation. So they've got to be representative of your data, of course, and they shouldn't obscure the meaning of your data either. And we see this, unfortunately, often in articles that people put together. The figures are hard to understand. The figures actually don't show what the authors think their figures should be showing. So again, things to consider before you get going on your article figure creation. So basically speaking, you're collecting different kinds of variable data, which could be numerical or it could be categorical, right? So numerical data, as the name suggests, these are numbers, whereas categorical data, this is often more qualitative, where you're putting things into categories, you're putting things into boxes, you're tallying up, for example, the number of trees of a particular height or animals of a particular weight, putting things into categories rather than just reporting counts. We'll start with numerical data first of all, because this can either be continuous on a spectrum or it can be discrete, 1, 2, 3, 4, 5, and so on. And the kinds of figures, as you'll see in a minute, that you will use, that would be appropriate to use to put into your article, depend upon the kind of data that you've collected. As I mentioned already, one of the very common errors that authors make is making the wrong kind of figure for the kind of data that they've collected. So you've got a hypothesis, you've collected data, of course. Now it's important to think about how that kind of data fits into this classification so that you know what kind of figure, table, graph, and so on you should be making with that data. And here we have it again, qualitative versus quantitative. Here's the graph, the table, the flowchart that I showed you on the previous slide, broken down in a perhaps more easy to understand way. My quantitative data, that's in the form of numbers or counts. with data sets having unique numerical values and almost always collected using direct measurements. Hence the name quantitative. We're counting something up. And as we've talked about before, the kinds of things that you might count up in your data could be discrete numbers of things, counts of things, or it could be continuous heights of things, areas of things, speeds of things. And I know that you're thinking now about your own research area, putting your data into these boxes. Maybe you haven't done this before. Maybe this is a new way of thinking about your data. Maybe it's very basic. But let me tell you one more time that one of the big problems that researchers often tend to have is creating the wrong kind of figures, or indeed doing the wrong kind of analysis. Now, speaking of analysis, just as a sideline, this is something that you should have looked at, you should have organized before beginning your data collection, at the very beginning of your research project. If you feel you need help with that, with research project planning, data collection, or data analysis, then do get in touch with Scott and I, because we work with a partner called Edance who can provide expert support in all of these project planning, data collection, and statistical analyses areas. Bentham are publishers, as you know. iGroup are our agents across Southeast Asia. We are now talking about how to present those data once they've been collected. So quantitative and qualitative, where we have the described qualities, characteristics, usually collected using surveys, interviews, or observations. So this is much more open to interpretation and hence nominal versus ordinal in the kinds of data that we would see in this particular example. So what kind of data have you got? It will feed in to the kinds of figures that you would be putting into your paper. So moving swiftly on, topic 2 of 4 in our presentation today, the different types of figures and when to use them. So we've talked already about thinking about what to do before you begin your figure creation. Now let's have a think about the kinds of figures you could be choosing to make when you're putting your figures together for your next academic article. So beginning with tables, and here we have a frequency table, and this is often a very, very useful way to start with your figure creation process. Even if you don't intend to present your data in a tabular format in your article, it's often very, very useful to make a table of data at the outset. And you've probably got this already in your Excel files or in your other data collection files. And here we're looking at relative frequency tables. And from these, we can go and make a range of other kinds of figures. But as an initial way of visualizing your data, this is a great start. A relative frequency table, in this case for hair color, it comes out of your data collection. And then from that, of course, we can go in and we can make a bar chart, probably the most common kind of figure that we see in academic articles. It's an abundance of something plotted against something else on the x-axis there. So here we're looking at populations, population levels in a range of different countries along the x-axis, and raw numbers, raw discrete variables up there on the y-axis on the left-hand side. Probably the most common way of presenting data, the most common way of sharing your data in your article. But it doesn't tell us all that much other than just raw numbers plotted against something else. Histograms give us something different. Histograms give us a measure of proportionality in our data set. And here we can see the data distribution, something that we couldn't see on that bar chart that I showed you a moment ago. We can eyeball this. We can see the range of measurements that have been collected by these researchers. We can see, of course, everybody will be looking at this and thinking, aha, a normal distribution. Our data are very quickly and easily visualized using a histogram across the distribution. What kind of data set distribution do we see in this particular set of data. So a histogram used to show continuous variables there broken down across the whole range of the data. So very common as well. And perhaps the second commonest kind of figure that we see in academic articles are pie charts, suitable there to represent categorical data, used to show percentages with one pie, of course, adding up to 100, and your areas on the pie are proportional to the value of the category. So you can easily see on this chart of my Facebook friends where the main proportions are. You can eyeball the data, you can put that in easily, you don't have to very carefully explain what's going on. So caution though, because lots of people do use pie charts to attempt to show historical data over time, and that's not a correct use of them. And you don't want to use the data as a fit in the frequency distribution either. So keeping your eye on the ball with the different kinds of data that you might be presenting, continuous versus discrete. This, of course, is a continuous kind of data presentation because everything adds up to 100%. That's your pie chart as a commonly encountered kind of figure that we often see in academic writing. And we have some graphics for you. We have some breakdowns. We have some information for you in this presentation that you can, of course, cut out and keep and use later in your figure presentations. Here's a breakdown timeline infographic. We see these often as well, very often in HSS articles, humanities and social sciences, for example. But you're very welcome to take screenshots. We'll give you this slide presentation as a PDF at the end of the presentation. Have a look at some of the graphics that we're using. Have a look at some of the templates that we have in this presentation. Hopefully they'll be helpful to you the next time you have to put together a series of figures for your next paper. What about a line graph? Not that different to a bar chart, I think you'll agree, but we're plotting years on the x-axis against sales on the y-axis. A simple way to show that, of course, Bentham and I Group sales over the last 5 years have been skyrocketing, as you can obviously see from this line graph. It's going up over time. That's what we wanted to present. In this case, a line graph is the simplest way of presenting that. And scatter plots as well. These are useful because on a scatter plot, you can easily see a data distribution. Down on the bottom right-hand side of this slide, a data distribution that has no linear relationship. And you can see the other kinds of commonly encountered statistical relationships within data in the other three components of this slide. Positive and linear, negative and linear, very clear. Those are negative and positive respectively. So one variable increases, so does the other. That's a positive linear relationship. One variable decreases while the other increases. That's a negative linear relationship. And then on the bottom left, that negative non-linear relationship as well. But these are scatter plots, very effective ways to immediately share with your audience data distributions. Now, as we mentioned at the beginning of this section, a summary table is your starting point for this kind of data presentation. This is a way to summarize your data. It records how often each value of each variable occurs, and you can build one quickly and easily by identifying lower and upper limits in your data, putting in the number of classes potentially. As you can see here on this plot of my Facebook friends, I've divided them up into groups of 50 along there on the far left-hand side. I've given you the frequency within those categories, the relative frequency, the percentage, the cumulative, so increasing as we go from category to category, and so on. So ways to show my Facebook friends as a data set. Very important to do this at the beginning of your results creation process in order that you can help yourself to discover what kind of figures you should be making. And here again, very, very common in this particular case, continuous data plotted in a very quick and easy to understand way. Very common in medical research, very common in all kinds of research that involves basic statistical analysis. It's our old friend, the box and whisker plot. In this case, we're looking at the growth of guinea pigs' teeth. The length there is on the y-axis, and I'm plotting that against vitamin C dose. And on this box and whisker plot, you can see the data distribution. And you can also see the mean. That's the black bar going across the yellow and orange boxes. The data distribution is shown by the extent of the color, and then the standard deviation, those error bars coming up and down from the top of each of the colored boxes. So from this, I've got a lot of useful information, quickly and easily presented in a graphical way. I know the data distribution. I know the mean, and I also know the standard deviation. Very easy, very quick, much easier to understand than if I'd written that or presented that to you in a table. We talked about scatter plots already, but these are also used for correlation. And here we've got our correlation coefficients are on the top of these diagrams. Almost completely linear positive relationship down there on the far right-hand side at the bottom with a regression coefficient of 0.99. A completely straight line, as you know, would have a regression coefficient of 1. And you can easily see on this figure which of my data sets is better correlated to another of my data sets. This is what these kinds of scatter plots are also often used for. So have a think about what you want to present, have a think about the kind of data that you've got and how you might put it together in your presentation. But don't forget that, of course, correlation does not imply cause. And we've all got millions of hilarious examples of this. You see one just on the slide, but just because two data sets are correlated does not mean, of course, that there's a causative relationship. Correlation is a statistical thing. It's a measure of linear relationships only. There could be a misleading influence of a third variable, spurious correlations of a part with a whole, combinations of populations, for example, that are unlike, or inferences to a population that is unlike the group that we are comparing. For example, sales of Bentham and I Group over the last 10 years against the number of shaved heads in the different countries where Bentham and I Group sell their products. Of course, the two things could very well be correlated, but as I'm sure you'll agree, we are making inferences there between two populations of data, sales and shaved heads, that are of course unlike one another. So there could be a correlation, but there's probably no causative relationship. Having looked at the different kinds of figures, we're now going to move on and have a look at 10 simple rules for making figures. Topic 3 out of 4 in our presentation today, 10 simple rules for making your figures. What are you going to do when you have to put together a figure for your next paper? And this is, in my opinion, one of the best papers ever written about data presentation. We give it to you in this presentation, free of course. You can download it from the PLOS Computational Biology website. 10 simple rules for better figures. If you haven't seen it before, please do have a look at it because it is absolutely fantastic, giving us 10 simple rules for better figures. And of course, rule number 1, we've covered already in this presentation today. You've got to know your audience. The kind of data, the kind of way I might present data about cancer to a bunch of cancer doctors reading the Journal of Cancer Studies would be different to the way that I might present those data to a general biological audience reading a journal like Nature or Science, for example. Think about how you're going to be presenting your data to your audience. And that's rule number 1. That's actually the first thing we talked about in this presentation today, your message and your audience. Getting that clear before you begin to make figures is very, very important. Rule number 2, of course, your message. Having that message in place before you begin is very important. Rule number 2 for making great figures. Rule number 3, of course, involves adapting to the medium. Here we've got the same data, but presented in two different ways. One I might use for a poster, one I might use in an actual academic article. And I think you can agree that probably in my academic paper, I would be using the data presentation on the right-hand side because it's simpler and easier to understand. Whereas in a talk or potentially on a poster, I might go with the data presentation on the left or both. It's all about adapting to the medium. And that's rule number 3 for making great article figures. Rule number 4, of course, is that your captions are not an option. A great figure needs a standalone caption. Very, very important to put all of the necessary information into your figure captions so that somebody reading your figure and the caption can understand what you're talking about without having to read the rest of the paper. And that's important because lots of people download just figures from the internet. They download just figures from PDFs. They don't look at the rest of the articles. So rule number 4, be careful with your captions and also be careful about your software. Use a software package that you're happy with. Don't be forced by your colleagues into using a software package that they think you should be using. As a geologist, I know this from my own research. Everybody used to say, oh, you should be using this particular software package. If you don't know how, if you're not happy about that, then that can make your figure standard decrease dramatically. Rule number 6, effective use of color. Here again, the same data presented in 3 different ways. Which is better? Which is easier to understand? Don't forget, of course, that many people out there are colorblind. They can't see what you can see when certain color combinations are used. Many journals allow you to put any colors you like into a PDF because that's the open access version of your paper. But there are still some journals, many of our wonderful Bentham journals, for example, that you may get on subscription from the library. And so there might not be color in all of the figures. So rule number 6, using color effectively. Rule number 7, don't mislead your audience. Again, the same data presented in 2 different ways. Relative sizes using disk area and relative sizes using disk radius. And you can see from the bar charts on the right-hand side, which one I use gives quite a different possible interpretation of the data. So don't mislead people. Be open, be honest, be ethical with your data presentations. Rule number 8, of course, avoiding junk. The graph on the left-hand side is very, very, very difficult to read and understand, whereas the same data plotted out as a series of data series is on the right-hand side is easy and quick and simple to understand. So rule number 8, avoiding junk. Rule number 9, of course, beautiful figures look great, of course, but your message is more important. And here's a figure that doesn't necessarily look fantastic, but it gets the message across. It does what it says on the tin. It is effective in showing what you want to say. Message more important than how absolutely fantastic your figures look to the audience. It's not an art class. We're not putting submissions into an art magazine. We're working on academic research papers. And of course, returning to that issue of software, rule number 10, find and use a tool that works for you. I can't emphasize this enough. I was put under lots of pressure as a researcher to use the standard software packages for the kinds of research that I was doing. Of course, if you don't know what you're doing, if you don't know how to use that software, if you're not confident, then fall back, of course, onto tools that work for you. Those are the 10 simple rules for putting together fantastic figures. In our 4th topic today, the bonus section of this Bentham iGroup SciTrain presentation, let's talk about tables. Sounds boring, but of course it's not. Your data tables are very, very important. You create them at the beginning of your process. They must be easy to read as you present your data. When you should use them. If a trend is not important, if there are not too many numbers, and of course, to complement other data presentation formats. Nobody wants to wade their way through a paper that just contains endless tables, but these are very effective as an initial way to present your data. Now, here's a few style rules and principles. Tables should not be filled with grid lines. Sort them. We read from left to right, top to bottom in English language international journals, and time goes from past to present. Increasing size from small to large, and when comparing numbers, it's much easier to have the numbers in columns than in rows. So round up your data. Left, right, justify those numbers. Be consistent and neat in your formatting. Time from left to right or top to bottom. Row totals on the right-hand side. Column totals at the bottom. Using space to separate your data, not lines. Consistent scales and units. Consistent number of decimal places or significant figures. And keep it simple. Very, very important. We've got a number of examples to show you of what to include. And here's some data from my homeland, the population of Wales. You may have noticed that my name is Gareth. It's a Welsh name. Here's some data plotted for the population numbers for Wales, 1901 to 1991. Which of these two tables is easier to understand? Is it table 1 or is it table 2? What do I actually want to get across? In this article, all I want to get across is the increase in population. It's much better. It's much easier to use table 2. Presenting all of the data may often be unnecessary and it may be confusing. Sometimes a simple table is better. Here are some simple tables. We looked at this one already. The relative frequency of hair color, the percentage of children in each hair color, category dark brown, blonde, and red. Easy to understand. Data comes out at you from the page, maybe backed up, maybe correlated, maybe in partnership with another kind of data presentation as well. We don't want to see tables like this. It's too complicated, it's hard to read, it's difficult to extract important information, maybe in your supplement, maybe in your online information, but not in the main text of your article. It's a big no-no. People get turned away from this kind of data presentation. They won't be able to follow what you are talking about. And of course, no prizes for spotting all of the many problems with this table in terms of formatting, consistency in units, fonts, spacing, and so on and so forth. But take it from us, we do see lots of papers. We have seen examples like this in articles that we've gotten at our various workplaces for editing. So there are lots of issues with tables, but simple rules that you can follow to make sure that you do a good job. So things to consider. Who's your audience? What are you presenting? What do you wish to show? And let's create a usable template for future work. When you put together tables in your subsequent papers, you've got a template that you can use, that you can come back to, that creates a consistent body of work for you as a researcher. Thank you so much for joining us today. With that, I'm going to hand back over to my colleague, Scott.
Gareth, thanks so much for that excellent talk. It was very helpful and illuminating. And for everyone joining us today, if we didn't answer your questions or your concerns about creating figures, then please feel free to type your question in the question box. If you have a specific question about creating figures, about representing your results, your data, choosing the right figures for your type of data, or any other topics that Gareth talked about today, feel free to type your question in the question box. We'll get back to you as soon as possible after the presentation finishes.
All right, well, thank you so much for joining us for today's presentation brought to you by SciTrain, Bentham Science, and iGroup. We've talked about things to do before you begin making your figures. We've also talked about the different types of figures and when you should use them in your academic articles. Then we gave you 10 simple rules for making figures from one of the best papers ever written about figure creation. And then finally, we talked about tables, which hopefully was not as boring as it sounds. Thank you so much for listening. If you've enjoyed listening to this presentation, then why not check out our website, SciTrain.com, where we have a range of 1-hour events and other training sessions that you can book for your university, library, research group, medical school, hospital. The list goes on and on. We provide training for researchers at all levels, helping you and your team get your research published in the best journals, planning your publications, collecting and analyzing data, creating great figures, and communicating your research with the world. So do get in touch with Scott and I at SciTrain if you'd like any further information about how we can help your research institute achieve success in academic publishing.